In this problem, we need to calculate the acceleration of the electron once inside the field. So looking at this electron, notice it's entering the field, so these lines are representing the electric field. And notice that I have a plate at the top, negative plate at the top, and a positive plate at the bottom. And so that's what creates the field. I have positive charges here, my field points away from positive charge and towards negative charge up here. And so when an electron comes in, it's going to be repelled by the negative charges and attracted to the positive charges. So it's going to feel a force down. So this electron, if I drew a free body diagram, it's going to feel a force F sub E for electric field down. And we're going to ignore the gravitational field because the electric field is much, much, much greater. And so we're going to say the gravitational field is negligible. So what we're going to do is we're going to say the sum of the forces on the electron is equal to ma. The only force we're considering is F sub E. And so we want to write, so the force due to the electric field, let me write that, E, is equal to Q times E. That's my force due to the electric field is Q times the electric field is equal to ma. And so I can solve for A is equal to Q times E over m. So plugging in my numbers, my electron, the charge on my electron is equal to 1.602 times 10 to the minus 19 coulombs times my electric field strength, and my electric field strength is 1500 newtons per coulomb. And so that would have been given one of my givens. So given the E is equal to 1500 newtons per coulomb. And then you're expected to know the charge on an electron, so this is an electron. And my mass of an electron, you probably don't need to know that. So the mass of an electron is 9.11 times 10 to the minus 31 kilograms. And we'll write E minus is equal to 1.602 times 10 to the negative 19 coulombs. I didn't write a negative there because I took care of the negative sign here because I said that my electron is a negatively charged particle, and so therefore I know my force is going to point down here. So if my force points down, then my acceleration's in the same direction. 9.11 times 10 to the minus 31 kilograms. And then when I work out those numbers, I get 2.64 times 10 to the 14th meters per second squared.